Okay, so we're standing in our Central Phoenix Revival project, and we are about 75% of the way complete with framing. Today we're going to talk about our roof structure and trusses. And so the way that we build roof structures and trusses today is a lot different than 100 years ago or so. So I'm going to break down the evolution of trusses, going from hand-cut rafters and ridge beams with precision carpentry to today's standard of roof trusses being built off-site at a truss manufacturer, and they're fully engineered. They take less time to install, which means less labor and lower build costs. So in the past, homes would be stick framed all on site, and everything was built on site using precise mathematics and geometry by really highly skilled carpenters. Much of that is still the same today. All of the vertical portions are built on site piece by piece, but when we come into the roof structures, what's changed is we're no longer measuring angles on site, calculating everything by hand, and then building each portion of the roof structure, whether that's the ridge beam, the rafters, all the vertical supports. We're not doing that anymore on site. So we build up to our top plate, which is where the roof connects to the vertical walls, and then we bring in engineered truss systems. Those are designed by architects and then engineers, sent over to a roof truss manufacturing facility, who then uses that CAD program to build all of the trusses off-site. And so some of the speed and efficiency that comes with that is that everything can be delivered at one time. Everything's made precisely. It's already calculated in for the roof load, wind load, solar, seismic activity, depending on the market you're in, and a bunch of other factors. And so what happens is the trusses are built off-site, delivered to your job site, fully ready to go, and then they can just be lifted in by hand or a crane depending on the height of the project. So we can do an entire roof structure in a handful of days versus something that would ordinarily take potentially a couple of weeks, if not longer. Another big technological advancement within the roof structure component of a build is the metal plates, or the metal connecting plates, commonly referred to as Simpson strong ties. And so it used to be that there was complex joinery, a lot of nailing, and very, very intentional work to tie the roof structure to the actual vertical walls or the exterior walls of the home. But today, it's made a lot easier and actually a lot stronger by using these metal plates. And so they connect and nail into the roof trusses into a specific nailing pattern that the plate is already pre-set up for. And then that plate connects down to the top plate of the vertical walls, and again has a very specific nailing structure that's a predefined pattern on that connector plate, which sandwiches in the roof to the walls and ties everything in nice and tight. So this is one of the connectors that ties in the trusses to the top wall. This is an H25 connector, one of many hundreds of them that are installed in this particular remodel. And it's something that we can move quickly through, and we know is going to be right every time if we follow all of the nailing patterns and then connect the top to the bottom, and we're good to go. Here's another larger Simpson strong tie, and this is designed to set multiple trusses in that need a hanger off an adjacent beam versus rest on top of a top plate. So as you can see above me, there's no top plate for these three trusses to connect to or sit on top of, and so we nail in a plate like this into the adjacent beam, and then we can set all of the trusses here, which makes the connection to that beam, and then that beam then carries the load of the roof. Oftentimes these are going to be used at roof transition points, and so where I'm standing now, we have a roof in front of me that's going to be transitioning into the opposite direction, and that's why we have that connection point with the change in trusses that run east and west to north and south. All right, so the question often gets asked, are engineered trusses and roof structures really something that helps with the budget? And I would argue absolutely yes, beyond a shadow of a doubt. When you look at the severe shortages of highly competent labor, carpentry being probably one of the most desired trades that we just can't find, what the average pay is for a really good framer or carpenter, and then the time it would take to conventionally frame a remodel like this or a new home, having the trusses engineered off-site and being able to install complex roof systems in a handful of days versus weeks or months is just significantly less expensive. It's a lower investment, and The reality is it's structurally more sound. We can now easily account for things like big solar systems or heavier roofs, be it tile or metal or other designs. And so from our perspective, any chance we get, we would prefer to have engineered trusses. Every once in a while you're doing an addition that isn't that big, or you're doing some work in an older home where it was conventionally framed, and we'll go back with the same style of framing just to carry on the same overall look. But if we can get engineered trusses into a project, we're going to do that every single time. It's what's best for the home. It's going to allow us to have the most longevity in the property. And when you're living in Arizona, which is a very harsh climate with the heat, we want to do everything we can to make sure that our builds last, through the test of time. So we'll take engineered trusses and any other portion of build science that we can to make sure that our builds last for generations to come.